Hello friends. Hello friends. Now we start the third part of unit first vector analysis. In this part we see first the partial derivative of vectors, a vector differential operator. So we start the first point, partial derivative of a vector. Partial means some part. So it is known as half part. Like this we say that it is uh, few part, not total. So it is known as partial derivative of vector. If a vector depending upon one or more than one scalars, just a minute. Partial derivative of vectors. If a vector depends on more than one scalar variable, let that is a equal to a x y z, then the potential derivative of a with respect to x is defined as dA by a by dA by x लिमिट. आता या ठिकाणी आपण काय कन्सिडर करतो, एक वेक्टर कन्सिडर केलेला ए ए इक्वल टू एक्स वाय झेड आणि त्याचा आपण डेरिव्हेटिव्ह घेतो with respect to x. So such type of derivative, it is partial derivative, therefore it is denoted by delta a by delta x, or dA by a by dA by x we say, equal to limit delta x tends to 0. आता या ठिकाणी डेरिव्हेटिव्ह कशामध्ये घेतलाय, विथ रिस्पेक्ट टू एक्स डिफरन्शिएट करतो, त्यामुळे चेंज जो आहे तो फक्त एक्स मध्ये झालेला आहे, वाय झेड मध्ये देर इज नो एनी चेंज. सो द चेंज इन vector a, it is shown by a x plus delta x y z minus original vector is a x y z, here it is given a upon delta x. So we say that change in vector a divided by delta x, or the change in that x component, it is known as dA by a by dA by x. Rules of partial differential of vectors are similar to those used in elementary calculus of scalar functions. So already we all of you know that in 11-12 standard we seen the elementary calculus of scalar function. Rule of partial derivatives of vectors are similar to those used for elementary calculus for scalar functions. Consider a particle moving along a curved path in a space. We consider one space, and that on that curved path the particle is moving. P is the position at some instant t. Here we consider that P is the position of that particle at time t. Position vector OP equal to R1, and the if it is a curved path, then O is the origin and OP, that distance, it is the radius of curved path. It is given by R1. R1 means its radius of that curved path. Similarly, if we consider that if we differentiate vector A with respect to y, already we have differentiate with respect to x. Now if we differentiate with respect to y, then there is change only in the y component. There is no change in x component and z component. Therefore, again same limit delta y tends to 0, ax y plus delta y z minus the original vector ax y z upon delta y. So here we differentiate delta with respect to y, you will get such type of equation, and similarly we get with respect to z also. So delta a by delta z, limit a x y z delta z minus a x y z upon delta z. So this is the derivative of a, that is dA by a by dA by z with respect to z, and here it is the derivative of a with respect to y. Now here it is shown, here is the origin, this is the point OP, it is equal to R1, and this is the curve path, this is the curve path. So here we consider this is x-axis, this is y-axis, this is our z-axis, and here in space, here we consider this point P. After a small interval of time delta t, let q be the position of the particle. Position vector OK equal to R. Means initially particle is at P. Now it will move to point Q, and the position of the particle Q from origin O is R2. Therefore, OK equal to OQ equal to R2. So this distance traveled by the particle within time delta t. The change in position vector in delta time t is, that is, delta r equal to r2 minus r1. The change in position vector, that is dr by dt, or limit delta r upon delta t as delta t tends to 0. So this is the change in position of the vector, position of the particle. Represent the instantaneous velocity v of the particle, that is rate of change of displacement per unit time. It is known as velocity. The rate of change of displacement per unit time, we know that it is known as velocity of the particle. Thus v is equal to dr by dt, limit delta r upon delta t, that is delta t tends to 0. Already we have seen that velocity is nothing but displacement per unit time, or the rate of change of displacement per unit time. Similarly, dv by dt is nothing but d2r by dt square. It is the acceleration, the rate of change of velocity with respect to time. It is known as acceleration, or it is d2r by dt square. Why? Because v equal to dr by dt. Therefore, it is differentiate, double differentiate with respect to r. d2r by dt square represent its acceleration. Thus, a equal to dv by dt equal to d2r by dt square. A vector differential operator, operator is written as del. This is known as del. This is vector differential operator. In Cartesian coordinate system, this inverse triangle, we say that for notation only, this del is defined as del equal to dabba by dabba xi plus dabba by dabba yj plus dabba by dabba z k. So this is the vector differential operator, del equal to dabba by dabba xi plus dabba by dabba yj plus dabba by dabba z k, and this is partial differential operator. Okay, the operator del is defined as del or nebula. The another name is this is nebula, or it is del. It is useful for defining three quantities which arise in particle applications known as gradient, divergence, and curl. So this del is useful. Where it is useful? It is useful in gradient, divergence, and curl. Okay, thank you.